Welcome to Conceptual Cambridge. Today we are going to go over differentiation. This is the beginning of your calculus journey. So let's get right into it. So first of all, what is differentiation? So differentiation is the process which is used to find the gradient of a curve at any point. So for example, let's say there is a curve. Let me draw it out like this. This is y is equal to x squared. So this is the curve we have, and if we are supposed to find the gradient at some point, for example like this, then we are going to use the process of differentiation. So now let's begin with it. So let's take 2 points, one this and one this. We're going to link them like this. Let's say this point is q, this point is p and q. So we have 2 points, so the coordinates of p, let's say we have x and we have y, and for q what we are going to say is that we have the coordinate x plus small change in x and y plus small change in y. So now you also need to know the gradient formula that we have already discussed in coordinate geometry, which is y2 minus y1 over x2 minus x1. Alright, so first of all, let me switch all of the coordinates into x. So for example, for p the coordinates will be x and x squared. As you can see, y is equal to x squared. So whatever the value of x is, we can square that. Okay. So now for the second one, it will be x plus small change in x and x plus small change in x, this will be squared. Alright, so we have our coordinates. So what I'm going to do is now apply the gradient formula. So let's see, let's take q as our y2. So what we have is x plus small change in x squared minus y1, which is squared, over x2 minus x1, x plus small change in x minus x. Alright, from seeing this you can cut this out and this out. So what you're going to get is, now let's open the brackets. So you have x squared plus 2x small change in x plus small change in x squared minus x squared over small change in x. So from seeing just this you can cut this and this out. Now what you are left with is 2x small change in x plus small change in x squared over small change in x. So now what's going to happen now, let me just rewrite it in a different form, which is going to be 2x small change in x over small change in x plus small change in x squared over small change in x. Now I can cut this out, this and this out. So what I'm left with is 2x plus small change in x. This is what I'm going to get as the gradient. Now since I only need the gradient at a specific point and that specific point is p, so what I'm going to do is make the change in x equal to 0. So it means it will tend to 0. The distance between the lines is going to decrease. So for example, there was a line like this, p and q. Now the distance, as you can see, this was the change in x. This is going to keep getting shorter, so like this, until we have it at point p. So this is basically what we are doing, and if we apply that, the gradient we are going to get is 2x. So from the curve y is equal to x square, the gradient we got at point P was 2x. So this is going to be the very basic first rule. As you can see, what I've done is, you can see the power of x is 2, so what I've done is applied that and decreased the power by 1. So basically 2x 2 minus 1 is equal to 2x. This is what I have done, and we are going to do this in the next slide. So now let's go. Alright, so now this is the very basic rule that is already given in your formula sheet. So as you can see over here, your function is basically x raised to the power of n, and the one you get after differentiation is nx raised to the power of n minus 1, as we just discussed before. So for example, let's say this was x raised to the power of 4. What this is going to become is, you can see, multiply it. So this becomes 4x, and then subtract 1 from the power. So 4x to the power of 3. So 4x cubed. So alright, and now what we are going to discuss is the notation. So basically there are two types of notation. One is known as Leibniz notation. So it is basically dy over dx. You have probably seen this. So what we are saying is derivative of y with respect to x. So whatever is down below, we are giving respect to that. So this is Leibniz notation. You do not need to know Leibniz. Okay, so the other notation is y dot. This is Newton's notation. It is sometimes also written as f x. As you can see in the formula sheet, it's written as f apostrophe x. So these are the type of notations that will be used, and we will also come across double derivatives. They will just have f double x, something like this. Alright, let's move on now. Alright, so now we are going to solve some practice questions, because for this topic you really need to practice this first. You need to be able to differentiate very easily. So let's begin. So let's see your first question, x7. We have to differentiate this. So let's just follow the rule. Let me just write the rule over here. Nx n minus 1. Alright, so what this is going to become, dy over dx is equal to 7x raised to the power of 6. So just following that basic rule. Okay, now for b part, what we have is 1 over x squared. You can rewrite this as x raised to the power of minus 2. So now we are going to differentiate this. Dy over dx is equal to minus 2x, and as you can see, minus 2 minus 1 gives me minus 3. You can rewrite this further and write it as minus 2 over x cubed. Alright, so part C, y is equal to square root x. So you can rewrite this, y is equal to x raised to the power of 1 over 2 first. Alright, now moving on, dy over dx, or y naught, is equal to 1 over 2x raised to the power of 1 over 2 minus 1, which will give you minus 1 over 2. So what this means is, you can take it down and write it as 1 over 2 square root x. So this is what it will become. And now for part D, what you have is y is equal to 2. Okay, so for any constant, the differentiation is going to be 0. Let me show you why. So if there is no x present, how are you going to solve this? So what you are going to do is add an x with the power of 0, because x raised to power 0 is 1. So nothing in this equation actually changes, but you can add it. So just you can apply the rule over here. So you can see 0 multiplied by 2, what this is going to be is 0 into x raised to the power of 0 minus 1. So what this will give you is 0. As you can see, the differentiation of any constant which doesn't have x will always give you 0. Alright, so now let's move on. Alright, so now here we have another beautiful question. So first of all, for this question, let me just bring all the x up like this. 3x4 minus 1 over 2 x minus 2 plus 4 x raised to the power of minus 1 over 2 plus 5. This is how you're going to rewrite any question that has x as a denominator. Alright, so now let's begin the differentiation process. So now 4 into 3, 12 x, and then 4, it will become 3. So minus 1 over 2 into minus 2 will just give me plus 1. So plus 1 x raised to the power of minus 2 minus 1, which gives me minus 3 minus 2 minus 1. Alright, so now 4 into minus 1 over 2 will give me minus 2 x raised to the power of minus 1 over 2 minus 1, which should give me minus 3 over 2, and now this should just give me 0. Alright, so now let me just rewrite it. 12x cube plus 1 over x cube minus 2 over x raised to the power of 3 over 2. What this means is that square root 1 over 2 and x cube inside plus 0. If you want further explanation for this, let me just explain why this happened. Because x minus 3 over 2. So first of all, you can obviously take it down due to the minus. So what we are basically discussing is x raised to the power of 3 over 2. As you already know, this square root means x raised to the power of 1 over 2, and what you are doing is multiplying it by 3. So basically x cube into x raised to the power of 1 over 2. So basically just x cube and square root. This is what it means. Alright, so we have our answer. Now moving on to another beautiful question. Alright, so as you can see this beautiful question, find the gradient of the tangent to the curve y is equal to x into 2x minus 1 into x plus 3 at the point 1 and 4. First of all, let me just write it out for myself. 2x minus 1 into x plus 3. Alright, so now basically what we are going to do is just multiply them. 2x square minus x into x plus 3. Alright, so now further multiplication. 2x cube and plus 6x squared and minus x squared minus 3x. This gives me 2x cube plus 5x squared minus 3x. Alright, so now what we are going to do is differentiate this. So dy over dx, which gives me 2 into 3 is 6 x squared plus 10x minus 3. This is the differentiation, and for this we are supposed to find the gradient. We are supposed to find a value, and they already gave you the value of x, which is at that gradient. So basically you are just going to insert it. 6 into 1 squared plus 10 into 1 minus 3. So this gives me 6 plus 10, 16. 16 minus 3 gives me 13. This is going to be your gradient for this question. Alright, that's it for part 1 of this video.